All right. Hi, everyone. Welcome to Monitoring LLMs in Production using Hugging Face and WhyLabs. I am Bernice Herman. I'm a senior data scientist at WhyLabs, and we're going to go ahead and get started. This is very difficult. I've seen others do it on our team, but presenting to no one, so I apologize for timing things. I do see a bit of the chat, so I will try to get caught up that way, and hopefully not going too fast or too slowly. So what you can see on the screen, and which will be shared by another member at WhyLabs, is a number of links. So one is to sign up to WhyLabs for a free account to our platform. We'll use this for the demo today. Another link for Slack group, and then links to the slides that I'm using today, and then the code that I'm using today in a Colab notebook. All right, so let's start with introductions. So as I already mentioned, I'm Bernice Herman. I'm a senior data scientist at WhyLabs, but I actually have a number of hats that I wear. So in addition to WhyLabs, you'll see right below that my university work. So I work in academia as well, and it's really nice to kind of bring things back and forth between industry and academia and gain knowledge kind of in different ways, see how things are applied very differently. So I'm here at the University of Washington in Seattle. And then this is on the right is a little bit about what I do for fun. So you'll see in the top corner, sometimes I like to develop games. So this is a game that I almost completed, but didn't quite complete earlier this year. I like to garden, or what I tell my husband is backseat gardening. So I tell him what we would like to do, and sometimes I do it myself. I like to play a lot of different sports. So I switch sports quite often. So you'll see at the bottom a picture of when I held on to a sport for 3 years in college, track and field at the University of Michigan. I also played track and field many, many years before that as well as weightlifting. I love weightlifting, so I've continued to weightlift. And then this is a picture of my husband with the fruits of our gardening labor. So now what do I do at WhyLabs? Well, I really enjoy working on kind of industry research and tools. So ylogs and WhyLabs platform are originally my main priorities. And so how does this work? So we'll talk a little bit about this diagram when it's more relevant, but as far as my introduction, I'm interested in 2 parts. So one is ylogs. This is an open source package for data telemetry for machine learning. And so what I do is I focus on the statistics side of things. Our goal is to take data, massive amounts of data in some cases, and find approximate statistics that describe signals in this data, right? So often large data sets have plenty of noise, and we want to reduce that both for management purposes, the ability to analyze it on one computer, that sort of stuff, but also just analysis purposes. So lots of statistics, lots of thinking about which metrics do we capture for data, for what type of data, and then how do we compress that into a reasonable size package so that we can do all of the things we need to do, especially in a production environment specifically. The other side of things is the WhyLabs platform. So there we take these profiles of data that ylogs compresses for us, and we do some analysis over time. So we're collecting this over time, we're visualizing, we're detecting anomalies, we're doing time series analysis, all of the sorts of monitoring and analysis that we want to do with our data as it collects throughout our life cycle. Okay. And then next, LangKit. So after we've kind of started that initial combination of tools, as LLMs became more popular, we had to think about how do our tools work for more complex data, like not only just text, but text that's generated, this really complex text. And so what we created is another open source package called LangKit. And this is really tailored to the text-based and LLM use cases in answering more specific questions that are important. So things like the quality of your data, sentiment, security, and governance. And here are some of the questions that our customers often think about and we think about. So how were my prompts and responses written? Does the LLM respond in a way? So when we have a prompt, we have a response. Is the response in line with our expectations? Do we have things like hallucinations or things where the explanation doesn't match kind of what we expect or what is the accurate answer? Are we leaking sensitive information? Can we find that just from the text alone? And many more questions. Okay, so now I want to hear a little bit about you. So if you're interested and able, share just a little bit about you, either in the YouTube comments or LinkedIn comments, wherever you are, your name, your company and role, and do you have models deployed in production? And if so, how does your team find out about issues that are happening in those models? This is something that I had to learn. So prior to working at WhyLabs and prior to working at the University of Washington, I worked at Amazon. And there we had massive amounts of data. Actually, many WhyLabs members worked at Amazon. And so we've really all been maybe scarred by the massive amounts of data that we had and learning how to deal with these things in production in real time, right? And how did we find issues? It was very, very difficult. All right. So I'll give people just maybe another 30 seconds or so to share about yourselves in the comments if you'd like. And feel free to share if you're job hunting if you are. Okay, I'm gonna keep going. So now let's talk about LLMs and generative AI. And the plus is we don't have to do a lot of this because we've all been inundated with lots of info about LLMs and generative models and what this means in industry, what this means in academia, many, many, many times over at this point. Okay, but assuming that you've seen this literature, some of this conversation that's been had, let's think about what we mean when we say generative models, because I tend to use this term because lots of things that we think about for LLMs apply more broadly. So for example, generative AI doesn't mean just text. It might mean code generation. It may mean image generation or voice synthesis for speech or 3D models or things related to different disciplines, so gaming or biology or chemistry, these sorts of things. And it's worth noting that there is becoming kind of a pattern that kind of starts with LLMs, where the input to these things are natural text, so prompts, as we call them. And then we have some system, we'll call them an LLM here, but maybe depending on the output, maybe we'll call this a different type of system that gives a response. And that response may be more text. It may be kind of in a conversational format that we see for ChatGPT and many other applications. It may be music, it may be code, it may be all sorts of things. Okay, but so what's a challenge? So when we think about LLMs specifically or generative AI, we start to get into lots of complex tasks and goals. So when you think of machine learning, maybe you say, okay, well, I know my classification metrics, I know my regression metrics, and this is going to cover a large number of cases. Well, that's not necessarily the case as we move into more large language models, more generative AI in general. We just have a large number of tasks, and we always have had a large number of tasks, but they have a lot of complexity to them, a lot of different ways of determining what a quality answer is, and requiring some complexity, maybe a model to determine whether or not an answer is high quality. There are also more complex issues to detect. So what you see here is actually a ChatGPT conversation where someone has asked, hey, summarize this article, and gave a URL. And the really interesting about this case is that this URL did not point to anything that exists. You looked this up, this just didn't exist. But the LLM, at least at this time, when they've created the snapshot, gave a response based on what I presume is just the text inside of the URL, hallucinating a web page where it wasn't there and giving an answer that is then a hallucination. Okay, so we talked a little bit about LLMs and generative AI. Now let's get to evaluation, monitoring, and observability, things that we need to care about for production. So evaluation, we're probably all familiar with. This is something that we think about when we're doing either experimental AI, right? So when we're training a model, when we're exploring our data, so on and so forth, as well as production. So evaluation, these are just a number of different metrics and things, just a cool picture to think about evaluation for. Evaluation often refers to a sort of evaluation in performance metrics that require ground truth. So you need not only the training data, but you need the labels for the data, right? You need some testing data that you've held out as well. And this is fine. What's the purpose of evaluation? The purpose of evaluation is to understand the quality of the model and how well that model generalizes to similar looking data. Okay, now let's move on to monitoring. So this is our first step into something a little more tailor-focused to production problems. So, excuse me. So monitoring, I propose, is kind of about analyzing changes in quality over time. So we see on the left something that's really typical, and this is experimental machine learning. So we have a training data set, and we may split this, and we may take out some held out piece and use it as a test data set, validation data set, so on and so forth. We may do more complex things like different types of cross-validation and so on. But the main idea is that we have static data sets that we've downloaded from researchers or collected on our own from our system, and we're using all of that data kind of as a snapshot in time. So this might be data that's been collected for the last 5 years, the last 50 years, who knows? But they all get piled together into one static data set. And this is pretty good for experimental machine learning, but doesn't really work in production, because once you get to production, you see a very different case where we don't just have one set of data. We have data that we're collecting every day or every week. And these data sets aren't quite independent, right? They're certainly related, but they do have changes across them. And what monitoring is important for is measuring those changes in quality of your data set or your model over time. And this becomes really difficult. I think the transition as a data scientist from experimental machine learning, where we all kind of start, to production and thinking about data over time can be really complex, and which is why there's a lot of monitoring tools that I'm hoping to share with you. Okay, and finally, observability. So observability goes beyond monitoring, which is about looking in time, and also thinks about pinpointing things within your system. So for monitoring, we typically think of what's the end result, maybe what's the inputs to our overall system, and what are the outputs to our overall system. But for observability, what we want to do is pinpoint issues within our system so that we can debug, so that we can fix our system. And so what does that mean? That means that if we have a pipeline, like we see here, of maybe features and a data pipeline, and then we take that data and we do transformations on those inputs and pass them into the model, and then we take the outputs and we do other things with that. Maybe we transform it before we send it to customers. And we then, eventually, depending on the application, get some ground truth. That is not always the case, unfortunately. but get that ground truth and find performance metrics, and then maybe go on to do things like business KPIs and look at actual customer impact. If we have this whole pipeline with all of this complexity, it might be helpful to not just collect data right at the model point, but collect data in multiple parts of this pipeline, so then we can understand what went wrong. So maybe we see some issue in our data, and we find it in the data pipeline, or we find things are working well in the data pipeline, but the feature transformation step seems to have some anomalies in the data or some differences from what we expected. This sort of stuff is really, really powerful, especially when you're dealing with production models, and all fits under this idea of observability. All right. So what's the problem then? So I mentioned ground truth in labels. And this is something that we expect to have at the kind of experimental machine learning phase, but may not have at all in the production machine learning phase. So in that case, we can do work as a organization to gather labels, gather information, but we can't expect those to be there, and we can't guarantee them to be there. So what makes this job hard about doing monitoring and observability for a machine learning system and making sure you can find issues in your system is capturing signal for model quality. So some things that work are capturing statistics. So things like quantiles and the overall CDF of your data, comparing that to other features in your data. This is a pretty generic approach and something that we have in ylogs in kind of an advanced way for collecting these things. But this works across all models, and works whether or not you have performance data. But the things that we're used to, things like performance metrics, accuracy, F1 score, RMSE, these sorts of metrics, these require ground truth data, and we may not have those. So other places you may look for signals for data quality are doing things like we'll talk about today with LangKit. So finding different instances or characteristics of your data and tracking how often that's present. So for data quality, maybe what I want to track for my text is what is the reading difficulty of my text, and what is the distribution of reading difficulties for all of the prompts that I've sent to my LLM, and all of the responses I get back from the LLM. So this is starting to be a signal for model quality, especially depending on your application. And lots of other complex metrics that you may have. So finding sorts of untruthfulness, finding things like disparity within a single response, this sort of stuff. And then finally, there are other metrics that are related to the business. So these might be something like user experience metrics, maybe net promoter score, or the feedback that you get from users. It may be things like business metrics, right? So if this model services some underlying product, maybe it's profitability or amount of sales or that sort of stuff. There's all sorts of signals that you can find in business KPIs that aren't, exactly correlated with model quality, but do help to capture some of that signal. All right. So now let's get to combining Hugging Face with WhyLabs. I want to ask a question of the group, so everyone in chat. Have you heard of Hugging Face? Are you familiar with that package? All right. Not seeing anything in chat. I wonder if it is me. Just check something here. Okay, cool. Yeah, so thank you for responding here. I wonder what's going on with my chat here. Oh, okay. All right. So Great. Glad to see people have heard of Hugging Face. So what do we have in common here at WhyLabs with many things here? I would say open source software for LLMs and AI. And this is a growing trend, right? Like there are many open source software tools that we rely on in this space. As a fun challenge, I have 5 logos for different open source packages, tools, models here. And if you can come up with all of them, you'll be great. But for WhyLabs, we also have a number of open source tools, and we rely on other open source tools like Hugging Face to help us out with coming up with these metrics and to calculate these metrics. All right, so first for our open source tools is ylogs. So ylogs is a data profiling and telemetry tool. And what data profiling means is this active reviewing and analyzing data sets to capture some structural information and some descriptive information about your data. So you might have seen many data profiling tools, things like ylogs, of course, but pandas profiling, many others. What are the sorts of things that they collect? Often things like descriptive statistics, mean, median, that sort of stuff. You may identify different data structures, types, or patterns. So you may note that, hey, this is all numerical data, or even more so, all of these data points are unique. You may look at the distribution of that data, but it can go well beyond that. So we may categorize data sets, we may use complex methods to kind of find proxies for data, look at correlation between data, all of this sort of stuff. All of this falls into the purview of data profiling. Now let's move on to our next open source, and we'll look at these in more detail in the code here. But this is for LangKit. So this is WhyLabs Language Toolkit, and this is about finding specific text and LLM features in your text data, right? And these can be really helpful for finding issues or signals that we talked about, maybe noting where we think something is highly likely to be a hallucination, or noting what the reading score is for something, or noting how different the prompt is from the response as far as sentence embedding similarity. Okay. And I just want to reiterate how difficult it can be to come up with metrics and come up with features that describe the quality of your data well. So just for fun, I wanted to switch from text over to images. Images are more fun on slides sometimes, although it's a little hard to look at the left. But this kind of shows, change over time. So in 2014, DC GAN was the pinnacle of generative adversarial networks for images, in this case, images of faces. And we see that they look kind of horrendous, right? Compared especially to what we saw even in 2017, which is also 6 years ago now. But the question is how could we detect this? How could we detect this at scale? How do we, other than opening up a number of these images every day as we monitor our system, how could we determine what the data quality looks like day to day or month to month even? So the thing that we need to do is collect features and metrics to describe either the data itself or some aspect of the quality of data that can give us signal. So I'm going to share some ideas for features, just looking at the left, which is hard to look at, I apologize, on things that you might ask for data quality. So there's, maybe things like general fuzziness, right? But how do you operationalize that? Well, that's a little easier to do numerically. We might look at the gradients across different pixels and say, okay, well, the gradients don't change quite as sharply as maybe some other images. So maybe we will call that fuzzy. Maybe there's some blurring that we can do in comparison to blurring of other images. But other metrics that might come to mind are things like, well, what are the number of eyes produced in an image, right? Um, is there some similarity to a composite face? Is there some ability to predict different attributes, maybe gender, maybe predicting, I don't know, any other kind of aspect? The task doesn't really matter what you're trying to predict, but the ability and the confidence in your model, in some external model, predicting these sorts of things may tell you something about the data itself, which is kind of what we're looking at. So what's the problem with all of this? Well, all of the things in bold here, all of these metrics are really complex, and they might require models of themselves. So for example, number of eyes, right? Number of eyes requires a model to do some sort of detection of eyes, right? And then there's different levels of confidence, different probabilities that you'll get for those things, and translating that to a metric that we can use to track our data over time becomes really difficult. Other things like using a model to predict some other attribute, right? This certainly takes a model. So this is just one example to highlight that as we move to generative data, where the data we're really focused on is complex like this, and the sort of questions that we might ask are complex, measuring quality becomes very complex, and we need lots of metrics to start to get some signal about the quality of the data. So for example, we see here that maybe number of eyes on the left doesn't always equal 2, although often enough may equal 2. On the right, we see 2 pretty consistently. Okay, so now we talked a little bit about both ylogs, which does data profiling of our data. We talked a little bit about LangKit, which is focused on finding these text-specific metrics, and often they're very complex, like we saw in our example for images. But let's move on to Hugging Face. So I don't work at Hugging Face, but this is an open source tool that we use quite a bit. And so I wanted to talk about this and how these two will combine together. Hugging Face is, if you haven't been there, is a hub for kind of data science and machine learning models, data sets, evaluation metrics, and APIs to access these things. And this is really great. People have put and continue to put state-of-the-art methods and models here. So what this means is that when we need a model to come up with a feature, using something like Hugging Face makes this way, way easier for us and allows us to kind of customize our features and continue to change these features over time. In today's presentation, when we look at our code, which will happen really soon, we're going to use 2 packages from Hugging Face. So one is the transformers package. This has a number of models that we can access and use, and have an API to access. And then also the evaluate package. So this has a number of performance metrics and things like this that can be helpful, especially when we have ground truth data, but we'll talk about some unique ways to use it even when we don't. All right. So now let's move over to the slides. So again, links are up at the top of the chat. Join us here at bit.ly/ylabs-hf-I-pi-and-b. So I'm going to click in here, and I apologize, that's not what you're going to see at the top. That's just a short link, but hopefully people are able to make it here. Okay, so what does this look like? We're going to kind of just walk through what it means to use WhyLabs, use ylogs, use LangKit, and then combine this with Hugging Face. And then we'll talk a little bit more about monitoring specifically. Okay, so first let's go ahead and maybe just introduce you to Colab if you haven't used it. So you should have access to Colab notebook that you can't edit. So if you want to make changes to yourself, which I hope you do, you want to run this, you want to add new prompts and things like this, please go up to File and save a copy in Drive. And this will make a copy for yourself so that you can edit. Okay, once you do that, you should click over to the WhyLabs observability platform to create a free account. So we're going to start this talking solely about the open source, but having a free account allows us to do some more things and do some more analysis, and it's free. So go ahead and click on this. This will get you to, actually, click on it too. You're leaving Colab, that's fine. And you'll get a page here. If you haven't created, you feel free to join our Slack community, but if you haven't created a WhyLabs account, click here. And actually, if you even have, you can click here to get to the login as well. So if you haven't, go ahead and put an email address in and a password and sign up. It'll do the standard thing of sending you an email, and you'll accept that. If you have, go ahead and log in with whatever credentials you already have for WhyLabs. I'm going to go ahead and log in myself here. I've used Google, but you can use whatever you like. And eventually you'll get to a page that looks a little bit like this. It'll be empty. I think you'll have a little modal that will pop up and give you some helpful new tips that I don't get. We'll come back to this in a little bit, but I'll give you a little bit of time to log in. All right, in the chat, please write in, just say logged in or done if you've been able to successfully get into the WhyLabs observability platform. All right, starting to see some dones. Awesome. Okay. Well, we'll let people continue to sign in. And when you get a chance, let's go over and set up by pip installing some packages. So admittedly, only the first line, pip install LangKit, will import all of the packages that we need because they are dependencies. But I like to put them separately here just to kind of get a sense of what we'll need. So you'll need to install LangKit, and we have this all extra here that we'll use. We'll install ylogs. We'll install 2 Hugging Face packages, so transformers, which will have a number of models or access to those models that we'll then download, and then evaluate, which will have a number of evaluation metrics. So this can take a little bit of time, probably like 30 seconds or so. Okay, and I am all set up. I'll give folks a little bit of time because I'm sure you started a little later than I did. But next thing that we'll do, I forgot to clear this when I was running earlier. Next thing we'll do is we'll import ylogs as y, just as a shortener. Okay, and once we do that, we want to initialize our session here. So if I type y.init, we actually get, when we're in an interactive environment like we are now, we'll get a question. about which type of session that you want to use. Either is fine. WhyLabs Anonymous works, but we're going to actually use some features that require the free account, which is why I had to make a free account. So we will say, number one, we're going to use an API key to upload to WhyLabs. And I'll show you how to get that API key in a little bit. So if you type in one and hit enter, then there's an ask for a WhyLabs API key. So let me show you how to do that here. So going back to our platform, we want to click on what I here called the hamburger, 3 different lines, the 3 horizontal lines, and we'll go to settings. Under settings, we have a couple of different options. There are 2 things that can be important. So the first thing is actually, well, the thing we'll use next. The first thing is the models. So you'll probably have empty list here. I have quite a few models. But what we'll do here is we will click edit models and versions. Oops, actually, I know what's happening here. I have too many models. So let me go ahead and delete just to be on par with you guys. Sorry, there's gonna be a couple deletes. I could have done this earlier. I don't think I need any models here. Okay, so now we're done with this. So I'll just get out of this. Okay, so now my screen should look a little more like your screen looks. I'm not getting any warnings. And we want to go ahead and add a new model. So now I see something at the top to create a model, and I can give it a model or data set name. Maybe I'll call this our LLM Hugging Face demo. We can choose a data source type. We don't have to pick the resource type, but in our case, it's going to be a large language model. So let's go ahead and scroll down and pick that. With the free account, we only have daily frequency, which is totally fine. And we want to just create one model. So I'm going to go ahead and press this. And what you'll see at the bottom is that you have a model. For you is, oh, you're seeing the video is very blurry. Oh no. Can other folks comment if you're seeing the screen is blurry too? Oh no, okay. Maybe I can try to reshare my screen here. Let me do that. I'm gonna stop sharing really quick and start sharing again. All right, so it's gonna be a little harder for me to see chat, but that's okay. I hope that this is better. Can people comment in the chat if this is actually improved? And let me actually set up so that I can see chat on my other device here. All right, let's see. How do I see chat on this? Having a little difficulty with chat, but I will just go back and check periodically. All right, so let's go ahead and go forward this way. Just hopefully it's more clear. I'll make this a little bit bigger now. Oops, let's try that. Okay, so we've created a new model, and it's worth noting the model ID that you've been given. So mine is model 22, yours is likely something else. And let's go back and go to our settings. So in the top here, you can click settings. Oh, okay, it's a slight. Oh, I wonder what's going on sharing wise. Okay, I'm just going to go this way, back to settings, and we'll go down here to access tokens. So in access tokens, you can get a API key that we can use. So go ahead and give your API key a name, an expiration date if you'd like, and hit create access token. And you'll see a little green pop-up with the token. You'll have to copy this over now, just it's typical, because you won't see it again. So copy that over, store that in a safe place, maybe a notebook or things like this, and then go from there. Okay, once you have that, we can come back here and copy that access token in. I stored mine just like this, so we'll do that. Way better if I'm not sharing my whole screen, but that's okay. And I can pass that in, and then we can pass it in the model. So I'm gonna go model -22 for me, but again, you probably have a different number. And now we see that we're using a session at my organization with the API key in the data set that we expect. So now when we log data, we're going to see that data propagated directly to the WhyLabs platform at that location. Okay, so let's get started. Let's first get some data. So we're going to learn about ylogs first, then we'll talk a little bit about LangKit, and then we'll talk about Hugging Face. So for ylogs here, let's go ahead and we're actually going to use LangKit to import some data because we want some LLM data. So I'm going to type from LangKit.ylog samples. There's a function, load chats, and then show first chat. So we'll just save the output of load chats to a variable chats. And what you'll see is this. So this format should be pretty easy for everyone to read. So we're taking a prompt and a response. We have 2 columns. This is a pandas data frame with prompts and responses as text strings. Okay. And when you run your LLM, you may have your prompt and response in different formats, but and there are different formats to pass things in. But I always like to come back to this because often I'm working with a lot of prompts and responses at one time. And so putting them in this sort of data frame format works well. Okay, so we can look through those, lots of fun things. These responses are mostly from Chat GPT, I think GPT 3.5 Turbo, maybe some GPT-4 in there. Okay, but let's talk about this. So we only have 50 rows of data if you scroll to the bottom. And at 50 rows, that's really tiny. But often in production, we have much, much larger data, right? And so just to motivate what we do here at ylogs and thinking about analysis at scale. So one alternative, so let's say we have many, many, many rows of data, so many that maybe we can't even store it in memory on our particular machine, or maybe it just takes a really, really long time to churn through it for lots of different analysis. And so, you may elect as a data scientist or a machine learning engineer or business intelligence to do this analysis, this heavy churning through your data. But what happens is that if you're answering questions every day about how is my system working, investigating certain properties, that sort of stuff, it's just really not viable to do analysis at kind of full scale. So there's a couple of things that you might consider to do to reduce that burden of analysis. And the first thing is randomly sampling your data. So I'm using pandas here to use the sample function. So chats.sample, And we're just going to take 5% of that data. Again, this is very, very small, but 5% is often reasonable. Sometimes it's 1%, that sort of stuff. And the positive of sampling is that, the format looks very similar. We have our raw text, but it can be really difficult to capture accurate trends. So for example, let's say of our data set, only a tiny percentage of those had a particular issue. What's the chances that our sample captured that issue on a particular day? Not very high, depending on the issue and how frequently it happens. And so this is a big problem. Something to look into then is something like data profiling. So this is a simple approach to data profiling that we also have in pandas, and that's the describe method. So I'm sure you've used this, but describe gives us some descriptive statistics here. What you'll see is that there's things like the counts, so the number of values, the number of unique values. So we're already learning something about this chats data set, and that is that there are 3 duplicates in this because there's only 47 unique prompts of the 50 prompts. The most frequent one, so this one is at least one of the, so this is the mode, so this is at least one of the duplicates. And then the frequency, so we see that we had 3. All right. But we're working with text data, right? So these are helpful statistics. We've already learned something about our data, which is great. So profiling can be really great for this. But there's lots more that we want to learn. And for text, it's really difficult to use these sort of standard statistics. So we need to think about ways of data profiling that are able to scale and handle complexity. For example, even just the distribution of different data, things like that. What are my quantiles? What are that sort of stuff? And in a case where we're working with large data and data that increases over time, we want systems that can work in a distributed manner, that maybe we can merge together, that sort of thing. So to do so, let's go ahead and log this data. So I want to point out that it's simple as y.log, and then pass in your data, pandas data frame here. I'm going to do this. So let's run. And we'll see that we aggregate the data into a profile, and we have a link to the data. So let's go ahead and click that. I haven't loaded any batch data. That's okay. Let's go ahead and look at our summary here. So let's learn a little bit about how WhyLabs works. So we see that we have one data profile, and we can explore that data here. There's lots of things that we can set up and read about our data set. I'm going to go look at our profiles, and we see that, oops, I'm flashing here. Apologies. This is a sharing issue here, so let me make this just a tad smaller. All right, let's do it right there. So what we see is that we have our prompt and a response, and we can capture interesting statistics and information about this as well. So lots of things similar to kind of what we might see in a profiler, counts, nulls, estimated values, that sort of stuff. But the interesting thing about ylogs is that we capture just higher fidelity information. So let me make this a little smaller here. So what we might see is not only just the data, but we might see a distribution of the data. So this is our frequent items chart. It has not all of the raw data, and you can elect to not store any of the raw data if you have a privacy sensitive application. But it does have things like distributions of our data, which can be really helpful. And we can look at this over time. Okay, let's go back. So that's ylogs, really focused on capturing this data, all of these different metrics that can be really helpful in this kind of profiling format, and then easily transporting that to a place where we can look at them, visualize them, and look at trends. Now let's think about LangKit. So LangKit is one step above this. So we'll still use ylogs under the hood, but now we want more interesting features and to capture some of the signal that we might have for text data. So what I'm going to do is I'm going to import a particular module from LangKit. And the one I'm going to import is called light metrics, just to be fast. So this is a subset of the metrics that we want to use. You're able to import many different modules or a larger subset of those metrics using different imports. But light metrics works really well. What I'm going to do now is initialize my light metrics. And what this is going to do is this is going to run and download models, some from Hugging Face, some other places, and initialize this, and it returns a schema object. So the schema object's important for ylogs. This tells us what sort of metrics we should be collecting for the data when we log it. So there's defaults that we saw just now, but we often want to customize these metrics. Okay, so let's go ahead and log again. I'm going to log my chats. Now I'm going to use my new schema that we got, and I'm going to give it a name just so we can distinguish between these. So let's run this. And we see the same sort of thing here, aggregated 50 rows, but now we have a name for this, and we can go back and look at this. So you can click on this, or I could have clicked back on the tab. And now we see our chats LLM metrics. So if you went to the previous tab, you can just click here and look at these. There's a difference between batch profiles and static references. I won't talk too much about this other than to say that reference profiles can be really helpful for training data or test sets, this sort of stuff that you're often wanting to compare. You can give it a name and always come back to this. When you don't have a reference profile, and this happened because I gave it a name. When you don't have a reference profile, you have what's called a batch profile. These are the data that we run for the day, that we log for the day, and they all get merged together. So what we'll see here is that that as we log more and more data, they all get pressed together so we can see statistics about our system, even if it happened in kind of disparate places. I just want to check really quickly to make sure. Sorry, I see many things. Okay, so people are having failed to upload profile, can't determine default data set ID. Yes. All right, so okay, that's unfortunate. Sorry that it wasn't optional. For folks who are having the failure, yeah, you might want to go back and run this again, passing in a default data set. Yeah, I will make sure to check into removing that optional or figuring out how to make it truly optional. But hopefully that resolves your issue. All right, and then go through and run this again. You just have to run this last one that we've done in LangKit. So goes right here. All right, so going forward, LangKit also has some really cool options in addition to just logging this information, which we can see here. We see all of these new metrics. So things like aggregate reading level, the number of characters, how many difficult words, patterns as far as data leakage. So if we have emails, if we have social security numbers inside of the messages, things about text, all text related metrics that can be really helpful in determining some of the quality issues of your data. And we're going to come up with some even more advanced ones. Okay, but before we get there, I just want to show that LangKit can also annotate your data here as well. So instead of pushing this here, question in the chat. So instead of pushing this here, we can see now all of our metrics. And I apologize, I just wanted to change the setup, but this makes this a little harder. So what is the data set? What to put? Okay, so when we did our setup here, we went to settings, we went to manage resources, and we have a model ID. That is the data set ID that we want here. So mine was model 22, yours might be something else. Hopefully that helps. let's go forward. Okay, so now let's think about how to add custom metrics, and then we'll talk about how to use Hugging Face with it. So for adding custom metrics, we need a new method called register dataset UDF. UDF stands for user defined function. So I'm just going to go ahead and import this here. And what this is a decorator that we can add to methods that give us new data. So this decorator here, register dataset UDF, which we start with an @ sign, takes in a list of the different columns that we want to apply this to. So I want to apply this to my response column, and I want to give it a name of response.text length. So there's already a text length example in that comes default with LangKit, but this is just a fun example to add on. So I might say something like, so now I'm going to give this a name. This is actually a bad name, but that's okay. It doesn't matter. I just need to return a list of the values that I want to log when I'm passed in new data. So we'll just run this, and hopefully you'll get a chance to kind of explore this in detail later. Okay, so now let's think about how we might integrate Hugging Face. So Hugging Face has evaluate, so we're going to import evaluate here. And let's think about a score. Let's say that for your system, your situation, you have a particular metric that your data science team likes to use. It's BERT score. BERT score happens to be inside of LangKit as well, which is great. But let's talk about what would happen if it weren't the case. We might use Hugging Face, which we use actually underneath the hood at LangKit to calculate BERT score. So I import evaluate, and this is a load method for loading a particular evaluation metric, BERT score. Let's see what's going on here. BERT score. Okay. Weird. Okay. So there's a dependency that I didn't have. Apologies. Let's go ahead and do that now. Pip install BERT score. Okay. All right, so I'll minimize this here. So now we have our BERT score model. Great. And we can now just see an example. So I'm going to grab the second row of our prompt or of our chats data set, grabbing the prompt and treating that as the prediction, and the response and treating that as the reference. These are just the parameters for BERT score, because BERT score was really intended for machine translation. So they had, some strong directionality about which is which. We just want to compare our prompt and response using the same score. So we're going to pass in a prompt into one and a response into the other, and give a model that we want to calculate the BERT score with. I don't have time, unfortunately, to talk more about BERT scores, but you can look into it. I actually discussed this at a little more length in various places, including the Deep Learning AI course that we have on quality and safety for LLMs. But BERT score gives us a number of scores. And so we could write a UDF that takes this BERT score and returns this. And now we have a function that can be included inside of our logging very easily. We're going to do the same thing. I won't talk as in detail about it with a model. So from transformers, we'll import pipeline. We'll import a particular model. This is a toxicity model, specifically an implicit toxicity model. Takes a little bit of time. And when that's done, we can test this on a couple of sentences. So the first one, maybe we expect to not be very toxic, but the second one, depending on the complexity of your toxicity method, once you see something kind of controversial, maybe a name of a racial group or something like this, may give a high toxicity score just by virtue of having that there. But being able to use Hugging Face means that we can use newer models or models specific to our use cases. Let's exit that there, sorry. To make that a little larger here, models specific to our use cases. And so we see that that's also not toxic. All right, so let's go ahead and create our UDF. So this is another function that passes out a list of some output of our model. So in our case, we want to take our label here and score. All right, now how can we collect this information? So I think I used it a little bit earlier. Yes, we did. So this UDF schema method, what it does is it collects all of the metrics that have been registered. And so this includes our UDFs that we've just created, as well as the ones that we've imported when we imported light metrics. So if I run this now sets our schema to include our new metrics. And so now what we can do is just log using ylogs. We'll give it a new name just so we can distinguish it, and we'll run. This is going to take a little bit longer because now we're running some more complex models, and we have kind of a warm-up cost here. So we'll give it a little bit of time, but this will log all of the new metrics that we've created, as well as the older metrics for our chats data. And then finally, since we're getting to time here, as we run, I'll talk a little bit about using Hugging Face for the LLM itself, right? So Hugging Face has some great options as far as LLMs. So we don't need to just do a model to detect different features. We may also use it for the LLM itself. So in this case, we have GPT-2. If we run this here, we can import our model, lots of little things. It's fine. Okay, and now we can use our model. So first what we need to do is tokenize our data. So I might say, what is the capital of Washington State? Just as an interesting example where this is actually not going to work. So GPT-2 is a much older model and may at least get this one wrong. So let's go ahead and ask the question. We'll generate a response, and then we'll pull out the part of the response that we need. And if we look at this, what is the capital of Washington State? The capital of Washington State is the capital and the capital of the United States. Right, so we tried, we got so close, and then we moved over to Washington, D.C. It talks all about Washington, D.C. So that's definitely a hallucination that we see. But this is because this is a pretty old model. So here's an example of a much better model that's also on Hugging Face. So this is Llama 2. So I won't import this here, but this is the code to do so, and we can just run that exact same code there. So that is it for my demo on this side of things. Now let's go ahead and look back at our profile data. So we could click back on the link here, or we could have also clicked on the link that popped up when we last logged. Let me just refresh. We won't look at the first batch. I think what we want to look at instead is our custom LLM metrics. So this is the most recent one. So not only do we have the metrics that we saw before, but we have our new metrics. So we have things like implicit toxicity, which I may have. Let's see here. Let's just do our BERT score to prompt. Oops, sorry, didn't mean to click on that. So if we go down to our BERT score to prompt and click view details, we see the same sort of stuff that we saw before. We see our distribution and box plots related to this. One thing I didn't show last time is that some of the metrics come with insights. So they give hints like, hey, there's email addresses in 2 of these sorts of issues, potential issues. And then finally, let's go ahead and look at a dashboard here related to our LLMs. Actually, we don't quite have enough data. So what I like to do is sometimes look at different data set. So if we go back to our project data dashboard, instead of going to your organization, there is a global demo organization that everyone should have access to. It's read-only, but it has some more data that you can really explore some of the new features. So I'm going to go to the demo LLM chatbot example. I'm going to click on dashboards, and I'm going to look at all of the cool things that you can see when we have historical data over time. So things like trends in how the sentiment changes over time. This is hourly data instead of daily. Things like monitors on top of these trends so that we can get an alert when one of these goes wrong, all sorts of stuff. I know I'm long on time here, so let's leave this here, and I'm going to jump back and check in on questions. All right. Yeah, so thank you guys so much. Sorry that we went a little long due to some technical issues there. I'll figure out what's going on with my sharing that's not working. I have a couple of other things that I want to wrap up with. So beyond open source, right? So we're using the platform to kind of go beyond the open source to do some trends. But more importantly, LLMs are beyond open source as well. So there's some really great tools, some really great LLMs on Hugging Face, but there's lots of others that I'm sure you've encountered, things like ChatGPT, that are not open source. And this causes new issues, new kind of reasons to come up with metrics to be able to understand things that are happening inside. We use the observability platform to kind of explore some of these things. And this fits into a larger system where we have our data, we capture statistics about that data, and then we pass those on to the platform where we can do all the sort of stuff that we've seen, plus more, plus forecasting and monitoring and alerts and that sort of thing. We've looked at our observability platform. And then that's it. So I'll wrap up by saying there's ylogs. So that's for data profiling and telemetry. LangKit, this is for text and LLM specific metrics. And then using WhyLabs observability to put all of these things together and understand our trends over time, visualize those trends, and build processes in your organization. All right. And with that, thank you very much. This is my first run, so some technical issues to work out, but I hope that you join me again for other workshops on different topics. If you have any questions, I'm going to stop sharing now and take a look at the questions. But thanks. All right. No other questions that I see here. So I will go ahead and close it up for today. Thank you.